happen. Or even worse, bad things can happen, but they may not realize that the bad thing happened until much, much later. So, clicking links is dangerous. The last time someone tried to mix business and pleasure, there were unfortunate results. So if you agree with me that it would be a better idea to keep them separate and not end up like this guy, then stay tuned. We have some things to talk about. Cookies. People cannot resist cookies. I mean, who can say no to a cookie? They're so useful, right? And they're small. I mean, honestly, how much damage can a cookie do? So people use cookies, and cookies can do all sorts of things. And at the end of the day, and we can talk a little bit more about, we will talk a little bit more about the types of problems that this can present, but they're ubiquitous. And I'd encourage you, if you haven't done it recently, to just go into your local browser and take a look at how many cookies you have and see if you can, plus or minus 50, recognize any of them. People love to download. They go to sites, they grab files, they download them, they run them. Oh, how cool. Look, I have an app that loads fonts, or emoticons, or what have you. If that weren't bad enough, there are several browsers. There's actually more than one. In fact, if you get into Safari for Mac, Safari for Windows, Chrome for just about anything you can possibly imagine, i.e., what are we at now? 7, 8, 9, 10, 11? 6 maybe not so much, but hey. And so there are lots of browsers. So not only do we have a browser that's got all of these different things going on in it, but there's lots of different types of browsers and devices. Right? Lots of different types of devices. I think you see where this is going, right? It just becomes this sieve with more and more holes, and the holes are different shapes and colors. And not only that, but there are lots of holes in lots of different places. So, again, just random daily map of suspicious activity distributed worldwide. The takeaway here is that yes, it may be concentrated in, actually it almost doesn't matter, but it's a follow the sun operation. So it's again pervasive and ubiquitous. Now, if we look at what I'd like to do now is start to delve into the mechanics of a browser. How many folks in the room have ever looked at HTML source code? View source. Okay. Anybody in the room ever maybe written a JavaScript widget or yeah? Or stole it? Yeah, exactly. Copy and paste. I mean, really, yeah. Right. Yeah. And you stored it right next to your cookie folder, right? Exactly. So part of the reason people click on links is because a human being looks at a page and sees it as a single object. Browsers, on the other hand, are looking at many different components. So depending on how familiar you are with web pages, you can use the developer tool. Anybody in the room ever use developer tools to look at? Okay. So, homework. Those of you who did not raise your hand, the next time you go to a browser, which will probably be sometime this evening, hopefully not too late, whatever your browser of choice is, there's likely to be an option that will say either view source or even better yet, view developer tools. Okay. The developer tools are going to illustrate all these different components. You'll see lots of menu options, and as you click on different menu options, they'll show you different types of objects. So you can see, for example, where the style sheets, where are the JavaScripts, where are the cookies, where's the network traffic. So the developer tool view is a great way to start to dig under the hood of your web page. Don't worry if you don't understand most of what you're seeing. The purpose of the exercise is just to give you a sense of how complicated and how much material you may have taken for granted and you may not have even recognized is there. So when people talk about virtual browsers, and the distinction that I'm trying to make here is that if you're going to the internet and going to lots of different places and downloading all this code, it's sitting on your machine, right? It's sitting on the same machine that has your contacts, maybe usernames and passwords for different services, emails, the lists of all the other sites that you've been to, your history file, etc. It's all adjacent, right? And so it's, for lack of a better term, it's local. Everything that's being executed in the web is local to the rest of your machine. So
where does this reside?
Exactly. So right now, we haven't left planet Earth yet.
Okay.
We're still talking about the day-to-day average experience of you've got a browser running on your desktop, or on your phone, or on whatever, your laptop. Right? So given that there are all these problems, and everyone agrees that there are these problems, with bad code coming into your machine, and possibly bad code coming into your machine and then being reflected out, turning your machine into a zombie, for example. There's an emerging consensus that the best way to fix it is to not run the browser on the same device as everything else. And so that's where they use the term virtual browser, right? In other words, it's a browser. But there's also the term maybe ephemeral browsers. I haven't run into that as much. Disposable browsers. The idea being that whatever you do in a particular session is so well sandboxed. Sandbox is a term that's grossly overused, but it's so well insulated that it can't affect the rest of your machine. And we'll talk about some different strategies, including very old ones that have been around for 20 or some years, and what might be different. And the object is for all of you to walk away from tonight's conversation knowing a little bit more about how browsers are constructed and the relationship between the different parts, and what kinds of choices you can make about rearranging those parts. Because again, we're used to thinking of a browser as a single page, flat, it's all in one package. We're not used to tearing the parts, the components apart. Does that sound like a good idea?
No.
And for the recording, the question was, where is this running? Where is this? Right.
Where does it reside?
Where does it reside? Right. So right now, in this slide, it's all, for the sake of argument, it's all running on the same place, same machine. Now, most people, humans, are really only concerned with the result, the output, right? The page that they look at with their eyes. They're not necessarily concerned with the intermediate components, right? The execution. And so part of the idea of sandboxing or making the browser virtual is to take those risky, unknown things, which are also unnecessary, and move them further away from the actual user. Move them further away from your data, your contacts, your passwords, your history files, etc. Where you move that is something that we can talk about over the next 2 minutes, but the basic idea is if the user's only really interested in the result, then give them the result and put some distance between the user and anything that might be potentially dangerous. This is an impossibly small slide. Let me give you perhaps a better, let's see if we can zoom in a little bit here. So let's look, I'm just going to go through a list of the various, I'm going to give you a list of the various components that might be subject to attack. And people often call those attack surfaces. So the first thing is network. Now, those of us who are in IT, and I include myself because I was a network operator for 6 or so years for a pharmaceutical plant in Palo Alto. That was an experience. Anyone here ever work in the chemical business? You don't know what you're missing. Talk about a bastion of innovation and risk-taking. So anyway, so when we think of networks, we think of course, the network that we own. We tend to overlook or take for granted the public Wi-Fis, the Starbucks, the access points that might be anywhere out there. And so as a result, this is a great place to intercept data or to misrepresent data. And so we call that a threat surface. Okay? Another threat surface, I'm just basically moving up the stack in terms of abstraction, is the keyboard. Is anybody here familiar with the term like a keystroke logger?
Yeah.
Yeah, keystroke loggers? Now, in a perfect world, a keystroke logger is something that you would use in an IT shop to record sysadmin's activities, and it's just part of your normal auditing, and that's wonderful. They can also be deposited by visiting a site that might have malware or opening up an attachment. You can, not you of course, but users can inadvertently install code on their machines that will track their keystrokes. And what makes them particularly nasty is that they can compare the keystrokes with the URLs that come in. So if you see a URL, you see the browser fetches a URL that's whatever, login.asp. You see that come across, and then you see the user type in something that looks like an email address, and then they type in a row of characters. Chances are that's a username password combo, right? So if you have these running in an automated fashion and they're reporting their results back to, Command Central in whatever, Bosnia or some anonymous Pacific island, that's one of the ways that they start building databases of user IDs and passwords.
Would that not bog your search down? Bog your system down?
So the question is, would that not bog your system down? So I think if I understand you, what you're saying is, if the keystroke logger is reporting these results,
That constant
with that constant traffic. Okay, so the short answer is that the amount of data that they need to transmit is really very small. In fact, it's safe to say that a username and password combination can probably fit into a single packet.
So they know what they're after.
And they know what they're after, and they're not going to. Right. The object is to stay under the radar. But yes, first question. I forgot to mention that. First question gets a T-shirt.
I didn't know that.
First question gets a T-shirt. But I should have advertised it. First question gets a T-shirt. We have a couple of other questions here. Other T-shirts here. So pay attention.
Cool.
Any other questions about keyboards being an attack surface? No? Okay. You can download keystroke loggers if you like. In fact, you could actually download kits. You can download a whole toolkit and make your own viruses, make your own keystroke loggers, go to jail,
Get fired?
If you get caught.
Only if you get caught, exactly. So, memory. All of this is kept in memory. And sometimes maybe the dividing line between memory that belongs to you and memory belongs to somebody else isn't always so clear. Files, contact lists. How many of you in the room have received a message from a friend of yours that they didn't actually send? And you felt comfortable because you saw that on the CC list were all of your other friends. How very cool. And they've got a little picture of a cat. So you go to open the picture of the cat, and then you get a very helpful message telling you that all of your data files have been encrypted, and that if you would like to unencrypt them, you can get the key for a modest $175 fee. And by the way, the software expires in 24 hours. I'm not making that up. Right? That's basically a loose description of something called Cryptolocker, which is like one of the more recent shenanigans that's going on around there. And I have to say, I have known some people who honestly were doing a really pretty good job of running a tight ship. But, it gets in and it just starts, because it does your disk, and then it does all the disks that are mounted on it. Okay. So memory is another attack surface. Plugins. Browsers are great, but they can't do everything. So there are often pieces of software, good pieces of software, useful pieces of software that are on the machine that are not inside the browser that you might need to use, like the Java virtual machine, Java runtime engine, right? Flash player. Those are two really popular plugins. Flash, exactly. Some people don't like Flash. Silverlight.
Silverlight.
Yep. These are all modules that essentially that the browser knows that it can send data to and receive data from, but once it hands it off, that's it. It's no longer responsible. So in effect, these act as gateways to other parts of your machine. And even inside the browser, every browser in the world is capable of running JavaScript. In fact, JavaScript was invented precisely so browsers could do more, have a more interactive experience. They could respond differently to clicks and movements of the mouse, capture data, figure out if you actually typed in a date, if it's the right format, that kind of thing. So JavaScript is a good thing. However, it's also easy to write. It's not a it's really just something that was designed to help make pages run more easily, right? It doesn't have inherently a security model with access control lists. The DOM. The DOM is, the DOM is really just a fancy name for the page and the pieces of the page. And the fact that there are, for example, DOM and HTML might be the same concept, but any of you remember there was a time, it still sort of happens from time, when they would put in white on white text so that you couldn't see it, but it was there, right?
Yeah.
And then scripts and links would happen, but you didn't even know they were there. Or there would be a link that was like 1 pixel large. Oh man! And you open the page and you think everything is fine. You can't see anything wrong with it. There's just 1 pixel in there. Right? So those are both examples of manipulating the content of the HTML page. You don't even need to run really very much code, but you can put stuff in there that that users won't notice, and take advantage of their regular activity to kind of tag along for the ride. And then finally, there's the user, right? And yeah, exactly. I got a chuckle from the audience.
Uncontrollable.
The user's the biggest attack surface of them all, right? There's the fancy word for this is social engineering.
I didn't do anything.
Hi, this is Bob Schwellenbach from IT. I got a problem here with your account, and I just need you to verify. Are you sitting on the floor 3? Yeah. Okay. Yeah, there's a problem here. Listen, I need to reset your password here. Hang on a second. Okay. So your old password was okay, fine. And what's your new password? Okay, got it. All right. Oh, good. You're all set. Thanks a lot. So these are different things, different components that people will attack. Probably not much that we can do about the users. There are companies that you can sign up for that will educate your users and give them little tests and send them sample phishing sites, and they try to do it in a nice way. It's not like, oh, you're busted, right? But they'll say, oh, you clicked on this link. By the way, did you know that if it says Bank of America, but this little thing up here is the URL, and if it ends with RU, then it probably isn't really Bank of America, that kind of thing, right? Incidentally, at a company I worked for recently that's in the search engine business, there was a kind of a gag, we would call it cheese. So if you walked up to a machine and it hadn't been screen locked, you could go to a site that was basically cheese, and cheese them, right? So when they got back, their screen would be locked for a period of time, and it would have all these different things. I got cheesed, I'm a cheese, and it would essentially advertise to anybody in the room that they had gotten cheesed. And there was a page where you could see, it was almost like a Facebook wall type thing, where you could see the people who had gotten cheesed and the frequency. Yeah, interns get cheesed all the time. At least once or twice, and then they figure it out. Okay, so So now, of course, they're talking about heartbleed, and there's all this big hullabaloo, right? Is anybody not familiar? Has anybody not heard about heartbleed? Or any questions about what it might be? No? You don't know what it is? Okay, fine. So heartbleed is the name. It's just a common name for a flaw in what's called the OpenSSL driver. So OpenSSL is the open source SSL package module. And somebody discovered that it has a very funny property, which is that in order to keep the session alive, it sends a little tickler. And its method for keeping the session alive is it sends, so I'm the client, for example, I connect to you as a server, and I say, whatever, here's a piece of text, and for me to make sure, it's 12 characters long. And then you echo it back to me. Well, they noticed that if that the server would actually return however many characters I asked for. In other words, if I said, here's a packet and it's 64,000 characters long, it didn't actually check if I was sending 64 characters. It would just give me 64 characters of whatever it happened to have in its memory. Yeah. And if I did it quickly enough, I could keep asking for 64 characters and it would just sort of move the pointer down. Yeah. So it wouldn't be a big problem if it weren't for the fact that a lot of people run OpenSSL. Like, a lot of people. Basically, all the major Google, Yahoo, Facebook, anybody who has large amounts of servers is likely to run OpenSSL. And OpenSSL was basically a volunteer project by a whole bunch of people who didn't really work very closely together. And, this kind of thing happens even in the best of cases. So there's some people would say, oh, there's this horrible new threat, vulnerability to the internet. And in some respects, they're right. In another respect, it's really just a very classic garden variety buffer overflow, buffer underrun, depending on how you look at it. This is, info security 101. However, these are other examples of similar types of problems where you connect and you basically get access to something, you become root. Right? But heartbleed is really, in some respects, nothing more than a going out of bounds, right? Getting access to data that's outside of the boundary that you asked for. And it is a very serious problem. It's a very serious problem because a lot of people, honestly, I suspect that given, and this is just my own opinion, given how well funded and how well educated a lot of these organized crime syndicates are, I would not at all be surprised if, in fact, someone did discover this vulnerability. They figure it's about 2 years old. This vulnerability could well have been known to organized criminals who didn't feel any real obligation to report it to the rest of the community. So, in a sense, for all we know, this is, it took however long to get discovered by the good guys. Unfortunately, it's almost like a weird type of zero-day attack because the information was published and people have been updating their SSL drivers, and it's taking time for those updates to make their way. Servers need to be rebooted, software needs to be, QA, documentation written, etc. So there are, in fact, still production servers out there that you can connect to that are vulnerable to heartbleed. Whether they have any useful information in their memory is another question. And the memory is what they call heap. So it's not necessarily all nicely laid out and organized. So you might get 64, of the 64K that you request, 32K might be one thing, 12K might be something else. So it's not quite as simple as some people might make it out to be. And there have been real-world demonstrations of this attack being successful. I only wanted to touch on that because in the event that anybody cared to know more about heartbleed, I figured I'd bring that up. It's kind of one of those current interest stories. So great, we've got this problem. We have a better understanding of what, how we got there and what, what we're up against. And the fact of the matter is, it is scary. And really, in a practical sense, my experience has been that it's easier to just hope for the best, right? Pull the covers over our heads. And we do what we can. We use whatever tools we have available, and we do the best we can, and life goes on. And hope isn't necessarily a strategy. So, here's a way of thinking about how to organize the different risks, considerations. So if one were to go about approaching this problem from a kind of a clean slate, I would suggest, a number of us would suggest, that there are three major areas, three major categories of concerns. The first is the identity problem. And identity is the question of who are you and can you prove it? For a lot of people, their first reaction is that's all I need to worry about, right? Username, password, that's security. VPN, that's security. Oh, I have my dongle, my multi-factor key. That's great. I'm good. Right? Those are all perfectly viable solutions to the identity problem. But that's not the only thing that we need to worry about in this case. The other question, we chose three categories, and I'd be curious to get your input, but the other aspect of the problem is policy. What rules apply? It's like, okay, I know that you're Loretta, but do you have am I going to let you read this? Am I going to let you write it? Am I going to let you copy it somewhere else? In other words, what can you do with your identity? What are you entitled to do? It's a policy question. And overall, there's the notion of, is it safe? Is it secure? Is it still, is my stuff going to be there when I come back? Right? Is it going to be, has anybody rifled through my things? So some people might use the term secrecy. So we have the question of, is somebody really who they claim to be? We have the question of, are they allowed to do what they're requesting? And is that transaction or is that activity going to be visible to only the right people? Is it? Can we be sure that it hasn't been tampered with? So, given that, here are some of the ways that we have tried to solve this problem in the past. Right? In the old days, there's the notion of. Just to recap. So, given that we feel like, okay, I have to find a way to insulate myself. I still want to connect to the internet, but I want to come up with a way where I can do that, do what I need to do, without the risk of getting my stuff stolen, having people impersonate my identity, ending up, losing data. So, Live CD is basically. It was originally a Linux distribution called Live CD, and nowadays it's often just used as a nickname for when you take a CD and you burn it. CDs are read-only. You burn an image of an operating system and a browser, and that's static. It can't be tampered with. So when you want to go on the internet, you pop that thing in, you run your browser off of that, and when you're done, you eject it. And so essentially, you're creating a temporary software on whatever machine you have available. Of course, the browser gets updated. Gotta burn it. You're shaking your head like, no! Oh, are you kidding? So yeah, this is what you do when you're in high school. You're on a budget. It's not a great. I didn't say this was a good idea. Right? I'm just going through the things, the strategies that people have used. It's a single user solution. It's very cheap, right? And if you've got graduate student slave labor, then you can just have somebody be, the CD monkey that week. And every time there's a browser update, which these days is about every 36 hours, they burn a new disk, they copy it, they give it to everybody in the lab. I love this one, the dedicated device. I don't know if you've noticed, has anyone seen where that you go to a website like maybe Facebook or Twitter and they'll say, our recommendation is to have a computer that you only use for business, right? It's like, oh yeah, absolutely. I've got a ton of, yeah, in fact, I have a computer for Wells Fargo, I have a computer for Visa, I have a computer, right? That's not, that's almost laughable. And yet, that's one strategy, is you have a device, full-blown machine, it only does whatever, it's dedicated to that one task. Variation on that, not a bad idea. Mr. Ultrabox, VirtualBox. You burn a CD, you make a file that's a virtual machine. And disk space is cheap. You can have a whole bunch of these. And in fact, what's really cool is you can boot an image, do your updates, and then save it as a different snapshot. So that's not a bad strategy. You can have multiple operating systems, you can organize. Still more of a single user, I mean, it would be kind of tough to share that with other people. It gets complicated very quickly. And of course, you certainly wouldn't expect, it would be even more difficult to make it on an on-demand basis. There are commercial services that do that, where you log into a website and they fire up a virtual machine for you. And you could even write, you could assemble a service like that. But it's definitely intermediate advanced, and you're going to be carrying a pager. Because things can break, go bump in the night, and if you're the one maintaining it, it's on you. If you do, the other downside is this does end up costing a lot of money, right? Because it chews up bandwidth and CPU, and if you're renting someone else's, they tend to charge you a little bit for the first machine, and then they give you a bit of a break, but then you start drinking the Kool-Aid and you realize it's just really nice, and you want to have a window here and a window there, and before you, and these 4 CPUs just isn't enough. So you add another 3 or 4 CPUs, triple the price. It can get very, very expensive. Someone out there is bound to ask, what about VPNs? So VPNs were fantastic, right? In 1995, when I was using dial-up at home, and I needed to print something on the color printer, VPNs, that's exactly what you need, right? It's a virtual private network. And, you're sitting at home, you've got your 9600 baud modem, doing point-to-point dial-up. What could go wrong? Fast forward, you're sitting at home, you've got your DSL, your machine's on all the time, right? So effectively, you've gone from being a remote endpoint to being this fully, beautifully appointed backdoor with a absolutely rock-solid connection, stainless steel pipe into the home office, and you're secure, right? Because that pipe is stainless steel. Nobody can look at that pipe and extract the data. The back door is wide open, right? It's a revolving door. People are going through, but so VPNs are great, right? Like I said, if you wanted to print, or pull something out of the internal, file share or SharePoint, what have you, it's a godsend. They're not virtual secure clients. If they were virtual secure clients, it wouldn't be VPN, it would be whatever, VSC. So a lot of people don't like to hear that because I just spent all this money on a Cisco box, I went to training, I've got my clients installed and deployed, everything's certified, I get that. And just the fact of the matter is, a VPN is built to solve a particular problem, and there's a reason why it doesn't really work as well to solve this other problem. I have, this actually needs a little bit of help, but I promised Rob that I would take a slightly more complete version of this and make it available to anybody who's interested. It's really just a list of criteria, so if any of you are in a situation where you want to compare and you don't necessarily want to reinvent the wheel, you're welcome to use these criteria, modify them. These are just some of the things that you can consider when you're comparing different tools. These are different categories of tools, the live CD, the dedicated machine. Admittedly, some of these are ridiculous, right? But I just put them there, as a placeholder. Deep freeze is a little bit like taking a snapshot of your machine. It's almost like VirtualBox, but it's not so much that you're juggling different images. It's just that you can roll back to a fresh, it's a deep reset. Very popular in open lab areas or library kiosks, right? Situations where somebody logs out, they walk away, the next person comes in and they have a brand new, fresh install. So not a bad idea. So if we were, given all the different things that we've thought about and talked about, if we were to design something from scratch, what are the kinds of things that you'd want to see? And there are actually products out there that do some of this stuff. Okay. In a perfect world, the browser would be running inside a different machine. It could run on the same device, but it tends to chew up a lot of bandwidth. I mean, that's the big trade-off with things like VirtualBox, for example, is that if you're using the machine for two different things, you've only got one machine, you're splitting it in half. And there's always going to be a little bit of overhead, right? If you're running, Windows Server on a Windows machine that's, also doing Office stuff, then you pay a penalty. So ideally, it's running on someone else's hardware, right? And you want that to be temporary. You don't want it to be lying around. You want it to disappear. You want it to only be there when you need it and to be gone when you're not using it. You want to make sure that only the right people can get to it. That's the identity problem, right? You want to make sure that you have as many different safeguards as you can, right? Multi-factor authentication. Does that ring a bell? No? Okay. So some people may have heard the term two-factor authentication. Some people have heard multi-factor authentication. A factor is an object that you present. It's like a key. And there's like a little nursery rhyme, right? Something you know, something you have, someplace you are, something you are. Those are, generally speaking, the four factors. So something you know, like a password. Something you have, like a key fob. Something you know, something. Oh, some place you are, right? Like if you're coming in from a secure, like a particular registered access point. Right? Something you are. At first, the first time I heard that, I thought, what are you talking about? And then I realized, oh, of course, CAPTCHAs. Are you a human? That's a really important question these days. Because if you're not a human, I may not want to show you the next page. In fact, if you're not a human, I may not even want, I wish I hadn't even accepted the last packet from you. So CAPTCHAs, it's a CAPTCHA. It's an acronym that, so an example might be when you go to a website like Yahoo, for example, they love doing that. If you do anything wrong at all, it shows you this weird garbled text, and you're supposed to read it and figure out what it says, and you type in the letters and numbers. Or sometimes it'll play a sound like from a party, and you're supposed to make out like what the word is that they're saying.
Not that one.
Yeah, and the really cool ones are the ones that are games, where they'll say like tic-tac-toe, tic-tac-toe, and then you have to like finish it, right? Or Another really popular one. Any ham radio operators?
My husband is. How's that?
I know.
Hey, we going here a long time.
Yeah. Well, there's a site. There's a site you can go to. It's a little electronics site, and they have like a little a diode, and it's got the little stripes, and then you basically have to line up. There's a series of colors down below, and you basically have to click on the values of like, okay, this is a 5, this is a 10. So you just have to basically decode what the diode says, the markings. It's like, wow, I thought that is such a great idea. It was actually kind of embarrassing because I hadn't really worked with like electronics in a really long time, so I had to like look it up. And they had like a little link, like, you know, if you don't remember how to decode this, click here, and then they tell you what the stripes mean. Anyway, so yeah, basically you ask the person a question that could not be answered by a machine, a robot. That's the idea of a CAPTCHA. And a robot isn't, I'm not referring to, you know, whatever, lost in space, but rather a script, a program, some machine. We mentioned identity. So you want not just to deal with the identity of the user, but you also might have these intermediate identities, like are they a member of a group? Are they an administrator? Are they an end user? Should their account, do I need to create their account? Or, you know, revise, remove it, or make some sort of a change. Create. That's what read. Yeah. Create, read, update, and delete. That's right. Thank you. Oh gosh, that's what CRUD stands for. Give that man a shirt. He bailed me out of a very embarrassing situation. So, users, groups, policies, right? So typically you're going to decide, okay, is this person allowed to do this? Is this person a member of a group that's allowed to do this, etc.? So ideally you'd want to have a way of arranging, of making those arrangements. In a sense, it's really nothing more than the tools that you probably already have in your local networking environment. I mean, we're not asking for much, right? When you're doing it in your local network, have it in your web framework as well. And yet, very few third-party web services, and I'm including, you know, the usual suspects. Microsoft does a better than average job, actually. But honestly, with all the work they've done on their local side, they could, I think Office 365 could be a lot better than this. Google, don't even get me started. I mean, the concept of an administrative framework is really alien to them. And they're finally catching up. Facebook, Twitter, nothing at all, as far as I can tell. I mean, you have like, your close friends, your favorite friends, your less than favorite friends. You know, that's about it. But that's just a way of arranging lists of people. It's a distribution list management system. So these are the kinds of things that you want to look for. And in a perfect world, if you have all this stuff, you want to essentially have an environment that is available to you and invisible to the bad people. And again, this isn't really pie in the sky stuff. I've basically looked at what there are, like I said, some products out there that do different elements of this. Some do more than others. So it's not science fiction. It is in fact something that, and certainly people have been talking about it for quite a while. So it's already here. It's just a matter of it becoming and it being this different way of accessing the web. It's already becoming it's kind of sort of like the new trend.
It's perceived to be pretty expensive, is it?
The question is that this type of security is perceived to be expensive, and I think that so first of all, expensive is relative, right? If you're a defense contractor, you know, billion here, billion there, pretty soon you start talking about real money. You know? But so again, expensive.
Yeah.
And there are, if you're going to outsource it, you're going to be cutting somebody a check. If you do it internally with some of the traditional tools that we talked about, you can translate some of that cash into, maybe time that you've already paid for. So I think that, well, my objective was primarily to give you a way of organizing how to think about it and to understand a little bit more what some of the different elements are and how you can rearrange some of the components. It's not a sales pitch. There are companies out there that I'm sure will offer, maybe discounts or, then you're just in the marketplace, right, wheeling and dealing. And the bottom line is that all of this is less expensive than it would have been 10 years ago, right? So,
Or
again,
being hit with a virus.
well, that's like insurance, exactly. Being hit with a virus can be really bad news. So that's all part of the whole risk analysis, and I'm not a risk analysis expert by any stretch of the imagination. So I'm probably not the right person to ask in terms of like ROI and. But the threats are real, and in some cases where there are regulatory compliance issues, people go. It can be really bad. People can lose their jobs. People can go to jail. There are definitely some regulations that have teeth, even though they may be silly regulations. They still have teeth. Any other questions? You already got a shirt, so you're not getting any more shirts, just so that we're clear on that.
Our biggest problem would have been the policy, because we're just now telling people this is the amount of data that you can see based on your job description. We've never done that before.
Okay, so the statement is that the policy activity is relatively new, and you're just getting to the point where you're establishing a kind of a scope of access for particular people based on their responsibility, their role, right? Some people talk about roles-based administration. So if your function is to access these pieces of data, and this stuff you update and this stuff you only read, now you literally you're limited to that.
Actually, we had a question.
Yeah.
Yes.
Would it be similar, like for local side view, like Active Directory, as a way to say you're allowed to do all these things here, but apply it to the internet as well?
That's a great question. The question was, would it be comparable to, or would it maybe even literally be possible to take my Active Directory policies, say for a security group or a resource, and apply them to an internet service? So there's kind of like a holy grail. I sort of jokingly refer to it as the holy grail, the grand unified authorization model, right? That's a great one. You definitely get a t-shirt for that. Which is that the notion that I can go to one place, and in that one place, I can store all the rules for any system that might be out there. That would be possible, I think, if we didn't live in a world where vendors tried to own you. And the reason I say that would be possible is because certainly in the academic world, there are plenty of examples of directory services, for example, that can be extended, and authentication modules that can be like PAM, pluggable authentication modules. So there are certainly examples in the non-commercial space of tools that are designed to be extended. For better or for worse, Active Directory is not one of them. And it's not always so easy to write a client for Active Directory if you're, say, using, an Android phone or, well, even an iPad for that matter, right? So yes, it would be probably a good idea. And I think the best that we can hope for is to have some kind of a translation table. So you have a mechanism that does deal with the internet tools, and then where there are intersections or overlaps with Active Directory, like maybe the username or the telephone number, you come up with some mechanism for having them related to each other, right? Some people might use the term directory synchronization. That may or may not be what you want to do. Some people might talk about getting a feed, getting updates. But yes, in a perfect world, you would just have a single database where you could store all the schemas, the outlines for what a particular package needs.
So is WebSense kind of like this?
Very good question. Do we have any more T-shirts?
I have one. It's
Oh,
gonna be
that's
a
great.
sleep shirt for you because we're out of the smaller ones. But there you go. Thank you.
So the question was, is WebSense kind of like this? Okay. So yes and no. In a sense, what WebSense tries to do is it's effectively a service that looks at information and URLs typically, pretty much just URLs, and figures out if they're, it's almost like anti-spam, but for the web, right? The reason that I'm hemming and hawing and making all this is because I've tried to look at the browser and just the components and the elements of a browser in such a way that if we were to do it differently, we could bypass the whole filtering problem altogether, right? In other words, in a perfect world, you're not, you get away from the traditional antivirus chasing of taillights. Like, oh, they hit me, I'm going to hit them back. Oh, they hit me again, well, I'm going to hit them back, right? And you'll notice that, you know, for whatever reason, there are vendors who have made a whole industry out of selling people updates. So, and in a way, what I wanted to do was to give you a way of thinking about there is a big part of the industry that's moving away from that because a number of people agree it's an unsolvable problem, right? Unsolvable in the sense that as long as you're in a situation where you can only respond to attacks that you know about, there's a gap between when the attack hits and when you have a protection. And they often call that 0 day. 0 day being the first day the attack comes out before anybody knows about it. Bad things happen, and then the protections start to be put in place. So for example, if you're lucky, the attack happens on the second Monday of the month. Because the second Tuesday of the month is Patch Tuesday. Right? Patch Tuesday is the day when Microsoft rounds up all of its different fixes that it's accumulated over the last month, and it does an update. You really don't want a bad thing to happen on the Wednesday after Patch Tuesday, because it's going to be a long month. Yes?
So you've talked a little bit about the threat landscape of a browser or
typical browser.
Actually anything at the moment. So it's up until the part where you said HTML, the rest of that's a threat landscape for everything.
That's a good point.
So you talked about that. You talked a little bit about segregating the browser from your machine so that it is in a different environment, a sandbox or whatever the case may be.
Yes.
But you haven't talked about how those two are then going to talk. You've taken your browser out of the internet, out of your computer, and you put it somewhere else.
Yeah, which could even be on the same machine, but yes, as far as the network is concerned, it's somewhere else.
Yeah.
Right.
So then how are those two talking and how they stay secure?
Right.
Because you still have a browser. You still have something connecting to the web. That piece is a browser. It might not be local, but it's still a browser. And if I can't have the ability to update it, does it make sense?
It does, and I think the what I neglected to elaborate on is that in most of these, like VirtualBox or in most of these scenarios, the relationship between the display and the actual executing code is not it's not really a data path, it's not an execution path, it's really just a transfer of bits. It still should be secured, but the idea is that whatever boundary you create, whether it's, you know, a virtual machine on a remote host at the other end of the world, or simply a VM running on the same box along with everything else, the link between those two should be something that does not allow, or that doesn't, there should be no place for code to transverse that. So ideally it would either be, typically like either a bitmap or some kind of representation that's not, there's nothing here executable, right? And there are different ways of implementing that. But by and large, for the most part, you can think of it as like running RDP, like a remote terminal session, or VNC, where all of the action's actually happening on this other machine, and you're just getting a movie of it. In terms of how it gets updated, it's true that you would need some channel to get into the administrative interface and to build this and to do that. And there are, if you're looking at a multi-user environment, then you're typically going to have like an administrative tool with different levels of access controls. If you're just looking at running like deep freeze or VirtualBox on your machine, then you're in charge. And so you just have direct access to it. You're basically building a machine, writing a picture of it to disk, and then replaying it. That is very true. That you do want to be careful, particularly if you're using something that really wasn't designed to solve that problem. You do want to be careful that you're not inadvertently running a tool here that has all the same attack surfaces that you thought you were getting away from.
Yeah, it seems like at the moment you're just pushing your threat model out one level, which has some benefit.
Yes.
My direct computer isn't being threatened.
Yes.
But all the web surfing that I'm doing, when I go to my bank and then I go to my Facebook page and then I go to that random site.
Yes.
That all is still happening on.
Yes, absolutely. So, so the question is, it's all well and good to put a layer of separation between like my local hardware, but everything that's happening inside that remote web session might still be, there still could be that cross-pollination. The simple answer, just as a kind of a concrete example, right? There are, not to name any particular company here in the Bay Area that does this, but there are actually virtual browsers that will only allow you, the administrator can specify a policy that only whitelists sites, right? So WebSense, for example, and I'm not picking on them, but just that category, they typically will have like a deny list of all the things that are not allowed, and so that list just keeps getting longer and longer. Another approach is to say, okay, here's the list of sites that are allowed, and I'm going to deny everything else. Because if the browser's for work, and I happen to know what the work applications are, right? And whatever, Reddit might not be one of them, then you have your list of sites. By the way, that strategy is a great way to break phishing. Because if you predefine the sites that you're supposed to go to, when somebody gets the link from B of A and they click on it, the browser will know, right? Because it's not, the links are different. Right? So however convincing the page might be, they're not going to get redirected because the administrators put a policy in. So that's one strategy, is you basically say, okay, instead of just taking all general random browsing that's happening here and putting it over here, I'm going to shrink wrap the applications that are important to me. And if a user wants to use a browser for something else, that's fine, but I'm insulating my important applications from whatever random traffic may be happening. Otherwise, I would certainly agree you're just robbing Peter to pay Paul and kicking the can down the road. So that's an important, and in fact, there are a number of companies that try to do that in a number of different ways, so you've got different choices.
So from a personal standpoint then, I almost don't care about my home computer. So my point would be,
is it new?
Why wouldn't I take
I wouldn't mind having an extra.
Well, why wouldn't I take, I guess if I get attacked, why wouldn't I take and then not do my banking and things on my home computer, but go to the sandbox to do my banking, not mix it with my Facebook and other stuff. Just run Facebook from my browser on my home desktop, and if I get hacked or whatever, that's my own dumbness.
Yeah.
But I kept as long as I don't put any of my banking stuff or passwords for any of my important sites, then I'm insulating myself in some ways.
Oh, absolutely.
From my most important stuff.
Yeah. No,
My
actually,
Facebook gets hacked. I care, but I don't really care unless it also impacts, say, my banking passwords.
yeah, that would be worse. Yeah. No, I agree. And in fact, just as a kind of an aside, I actually got a call one day from a guy who runs this instrument calibration lab. It's super high-tech stuff. He's like the metric guy for the local Bay Area biotech companies. And he says, I've been using this virtual browser for a while, and I know for a fact that my machine has malware on it. But I've got dozens of applications, Windows machine, dozens of applications. I just don't have the time to tear it all apart and reinstall it from scratch. So I've been using this virtual browser for a machine that's known bad, so I can get to all my, he runs a small company, my payroll, my banking, and send test results out to customers and all that. So yeah, you could one way is you've either got a pristine machine that you want to keep pristine, or you've got a dirty machine and you want to keep the apps clean. Those are both, plausible.
And from a service desk perspective too, and I don't know if you guys still get a lot of password reset calls, but if you can control the credentials of the product that's out there, then they can log in securely, and you don't have that stupid call all the time. You control all that.
So the reason I felt strongly that we talk about the administrative stuff is because ultimately you guys run help desks, right? So your bread and butter is
Service
dealing
desk.
service desk. Your bread and butter is working with other people's equipment, right? So if you were just running your own machine, it wouldn't be a big deal. But you've got to think in terms of scale. You've got to think in terms of, users doing things that may or may not be the right things to do, and now it's up to you to find a way to solve that. So that's why I argue in favor of policies and administrative controls for your scenario, right? I wouldn't necessarily, it may not be relevant to a home or single user, but anytime you have a group of people with different responsibilities, you're going to want to have some sort of framework. Getting to your Active Directory question, right? That, I encourage you to insist on having the kinds of controls that you would normally have for your local environment. You should have them for the web. There's no reason not to. The technology is available. Yes?
I would slightly argue that it's not that there's no reason not to. So I work at UC Davis. I have a very diverse group of people. Most of them have academic freedom. They can do whatever they want.
Sure.
In that same group, I help the military science group. They don't have academic freedom.
Okay.
I have so many problems with the military science group because their stuff can only be updated, like if you update from IE6 to IE7, it will break. We're on IE11. So because of that,
specific military applications from the Army.
Right.
So, and they actually, every time something goes wrong, I have to go into the IE tool, recalibrate what it needs for the military software, and then I have to go in and say, okay, IE9, IE11, run as if you're IE9, and then it will work. So, because of compatibility. So I would slightly argue, although it's a very nice idea to have extremely tight controls in your browser, it can break usability.
Yes, I'm sorry. I wasn't suggesting that the tight controls be exercised. I think what I was trying to say is that having the ability to apply a rule to multiple people at multiple objects at the same time, having that ability is an important resource to have, and it's very often not even available. The scenario you're describing in terms of, shall we say, vertical industries that are, really idiosyncratic in how they maintain stuff, that is really, it's scary, but it's the triumph of process over results.
One of the solutions we've looked at is using a virtual environment where we can have the pristine virtual environment that we can do like something like deep freeze, where we can roll it back to a known goods or a known working snapshot, and then we don't have to care about the individual end user workstations.
Right. So the comment was that if you are in a situation where you have a customer configuration that's really brittle and idiosyncratic and peculiar, then just find a way to snapshot the whole darn thing, keep it on file, and if they mess it up, then you basically just push back, a fresh copy. That's a great solution as far as I'm concerned. The tricky thing is not so much with internal applications, because I think in many respects we have tools for like the ones you described. I think what's more challenging that people are starting to struggle with is those third-party web applications where you don't control the server, right? And it's the passwords are managed by somebody else, and it's all off the reservation.
Another question, right?
Yeah.
I currently do a service desk for a local government here.
Okay.
When you say about policy, we're actually a customer of all the departments. Each department has their own policy, and we can't dictate to them a common guideline, or we would like to.
Right.
But it's very hard to get them all on board with the same stuff at the same time.
Yeah.
Because we're working with multiple environments. We just now got off of 2003 and XP. So we have people who are...
Just in time.
Yeah. We have isolated everything.
We're not.
And the thing is, with that, we have people who are Windows 7, Windows 8, and everything in between, the different versions of different browsers. We found some applications work on this one, but break on this one. So it's hard to get exactly everybody on the same page.
That's why I call the universal authorization model, I call it the Holy Grail. Because even if you had a database, even if you had a directory server that could accommodate all those different rules, right? You would literally you'd end up with different organizations having different rules for the same object, the same person. And I mean, it's messy. There are companies that have taken that on. Centrify, for example, does this amazing wizardry where you log in with your Active Directory ID from a Mac, and they translate the Windows privileges into whatever the Mac filters, which isn't always, it's really hard. It's hard to do even to begin with. I never said any of this was going to be easy. Did I? I never said that, right?
Gets more complicated.
It gets more complicated. Maybe. I think so. My hope, my optimistic outlook, so to speak, is that part of the problem that we're having is that in the 90s, and 80s and 90s, we grew up in a world where it was multiverse, right? So if you think of like an Active Directory, that's like one universe, so to speak. And then there are other universes that can communicate with it. So you've got this tree, and then you've got this forest, and then suddenly you have a whole continent, and then you've got this whole interstellar, construction. But I think that what is hopeful is that the internet, so to speak, DNS, is fundamentally open-ended. Right? There is no boundary that you're going to run into. So as a result, it accommodates whatever you need to incorporate into it. It doesn't have this problem of like, oh, this is root, but then this is another root, and then that's another root. So I think that as we move towards, if you think about it, you've got, say, a Gmail account or a Yahoo account. You take for granted that you've got a file. You can share it with anybody who has an email address. Granted, there are still, seams, but in the old days, if you're in an Active Directory, you can't take for granted that you can give anybody in the world access to this, because you'd have to create an account for them, and then, and you wouldn't know when to delete it, right? Because you weren't necessarily sure when they wouldn't need access anymore. The adjustment, so to speak, is this notion of defense in depth.
Mm-hmm.
So you're not really so dependent on a perimeter and a predefined boundary or scope. You're basically saying, okay, this person or this printer or this resource has these various attributes. And the example of that might be, for example, in Google Docs, right? You can decide, okay, any random address out there, you can give somebody, read access, comment access, etc. And they don't ever really take the file away. They're all accessing the same copy of the file, right? So you're no longer living in a world where you have multiple email attachments dispersed and nobody knows when. Do I have the most current version of the spreadsheet? Oh, man, you changed it. Now I've got to merge your updates into this, right? So instead, what you're doing is you're trying to consolidate the data into one resource and then applying different levels of security to it. So in a sense, the security travels with the data, and since the data is not being spread all over the place, you're kind of arranging things differently.
Back to security, do you see the industry going in the direction of proactive security measures against hackers and such? Or are we still kind of in the Wild West, dealing with our own security individually at our individual levels?
So the question is, do I see the security moving in the direction of being more proactive with respect to attacks and hackers? The short answer is yes, absolutely. However, I don't necessarily think that it's happening evenly. So the heavy hitters, right, the Amazons, the Googles, maybe even Facebook for that matter, on their back ends, it's a whole different scene. I mean, the kind of equipment and the kind of operating systems and the kind of tools that they use would be completely incomprehensible to someone who's grown up in a traditional enterprise computing environment where you have a server with files and disks. They don't deal with any of that. It's the concept of a server. It's not a physical machine, but rather a place where you send requests and you get results back.
Gotta be something.
There is, but it's not in anywhere in particular, right? So it's almost like peer-to-peer networking, like Windows for workgroups.
Yes,
Okay.
still remember.
Good, thank you, please. Where every machine on the network has its own little identity, and you can just kind of log in, or Banyan Vines, where you basically just log in and you get, right? Okay. It's a much more abstract concept. Okay. So for an example, just to let you guys kind of spin around a little bit, random access memory. In the old days with DOS, you had 640K of addresses you could access. I mean, who would ever need more than that, right? So, and what that meant basically is if the computer is going to store some data, it's going to assign a location to it, and then that's where it would put it. And that's typically, mechanically, it's done by putting chips into that machine. Now, if your addresses, instead of being 640K, if your addresses could actually be 64 digits long, that's a really big number. It's big enough that a memory address can include an IP address and a port number and a process number. So you can literally, if you had the luxury, right, this is something that rich people can afford to do, but if you had the luxury of rewriting your operating system from scratch, you could now say that, the third byte of this file is at this location. And that location can actually be an IP address associated with a port. And when you finally get there, you don't actually get a file. What you get is a machine that's running an index. And that index says, oh yes, the first byte of that file, I happen to have 6 different copies. And here they are. You get those 6 different copies. Since you only really need 2, you grab the first 2 and you get on your merry way. Okay? That's how you can be anywhere in the world and open up your email or watch a YouTube video. You know, doesn't it seem a little bit weird that you could have an email message and get on a plane to Johannesburg and log in and it doesn't take any longer? That's because they're not putting the data all adjacent to each other in one little tidy place in Nevada. It's literally spread in multiple places. And when you make a request, you're basically doing all of these index lookups. And if they don't have the data local, they don't respond. And you don't care, because you only care about whether you get any data back. And as soon as you get 2 copies of the same thing, you're good to go. And if you get more, whatever, right? It's just bandwidth. There's plenty more where that came from. So those guys are doing very heavy-duty things with security, because now you can be a system administrator of a box, but it doesn't matter because there's nothing on that box. There's just a whole bunch of random bits, and you don't know if those bits belong to data, if they're executable code, if it's cache. You don't know what those bits belong to. The only way that you would know what those bits belong to would be that you'd have to also be a system, which by the way is going to happen, you'd have to also be a system administrator for the file system tools, the directory service tools, the memory management tools, defense in depth. It's not like the machines that you and I grew up with were designed with the assumption that the person putting the box together also had the right to look at everything that was inside. That's why everything seems to be bolted on, and there's seams and cracks and things. What we're looking at now is a whole generation of people who, having grown up in that world and frustrated by it, were suddenly given a blank check and say, here, you have clean slate, unlimited funding, build a computing environment that solves this problem better than anything else, and if you don't get it right the first time, just try it again. It's just money, right? There's plenty more where that came from. So what we see as end users is basically like kind of a little bit of a cardboard representation of a dollhouse as far as they're concerned, right? So that we're not shocked by the real thing that's happening back there because it's like Spock's name, you could never pronounce it. So you log into Office 365 or Facebook or Google Apps and you see something that's familiar. Oh gosh, this looks like a word process. Oh, this looks like a picture. Oh, it's familiar to you, right? But the reality is on the back end, it's not at all like what you're used to seeing in a traditional computing environment. Oh, anybody who's really technically interested, there are open source versions of a lot of these things, like Hadoop and MapReduce, trying to remember now. There's another database type. But yes, there are. You can figure out how to build these massively parallel clusters. If you're on a tight budget, you can. There's a little thing called a Raspberry Pi, which is a single board computer for like $35. Right? And there are people out there. You can look them up. They've taken like a few dozen of these, made like this massively parallel supercomputer that fits on a kitchen table. So it's a whole different scene. Sorry, I really went over.
No, all good. No, we've got 10 more minutes, but I think I feel everyone kind of wind it down a little bit because you're amazing, but you get people spinning.
So I think you guys, if you are interested, sorry, I'm checking the back here. If you're more interested in authenticating what they do, I think you guys are willing to stay and talk and that kind of thing.
Sure.
We've got paper.
Sure.
Yeah, and there's some more information on the table outside, okay? So, round of applause. Thank you so much.